Hi everybody, welcome to our anaerobic digestion video series. Today we are going to cover the topic of oxidation reduction potential, or simply ORP, in anaerobic reactors. ORP is of key interest in wastewater treatment plants that treat industrial waste, since many industries use oxidizing chemicals such as peracetic acid, peroxide, or bleach for disinfection purposes. Understanding ORP allows operators to manage their anaerobic reactors in correct ranges for the ORP values. It also allows them to take timely corrective actions if necessary. The oxidation reduction potential, or simply ORP, of a water sample indicates its ability to reduce or oxidize another substrate. ORP is measured in millivolts using an ORP electrode. As shown in the diagram here, methane production happens at a very low ORP range, starting at -175 millivolts. The most ideal range for methane production is -300 millivolts or below. Volatile acid production occurs between -100 to -225 millivolts ORP. And these are the typical ORP values in pre-acidification tanks of high-rate anaerobic reactors. Sulfate reduction starts at +100 millivolts, and hydrogen sulfide is formed between -50 millivolts to -200 millivolts, indicating that hydrogen sulfide formation has a strategic advantage given that many raw wastewaters have -50 to -150 millivolts ORPs. Sulfate-reducing bacteria responsible for sulfate reduction and hydrogen sulfide formation have an advantage over methanogenic archaea. These bacteria consume 0.67 grams of COD per gram of sulfate reduced. However, this consumption does not contribute to methane production in the anaerobic environment. Additionally, sulfate-reducing bacteria compete with hydrogenotrophic methanogens for dissolved hydrogen gas. A 150 mg per liter dissolved hydrogen sulfide concentration in the reactor liquid can severely inhibit methanogenesis. If industrial wastewater contains unspent active oxidizing chemicals, it can disrupt the anaerobic environment by increasing the ORP, harming the methanogenesis process. In such instances, the addition of reducing chemicals such as sodium metabisulfite or sodium thiosulfate can mitigate the oxidizer toxicity by lowering the ORP of the wastewater. However, this strategy may temporarily increase hydrogen sulfide production from the reactor until the added chemicals are totally consumed. Care must be taken to ensure the reactor does not exceed the toxic concentration for hydrogen sulfide. Moreover, the biogas handling system should be able to manage this extra hydrogen sulfide production, and the anaerobically treated wastewater during this phase may generate hydrogen sulfide-related odors requiring additional treatment. Well, this concludes our discussion on ORP in anaerobic reactors. I hope this provides enough information on the ideal ORP ranges for successful anaerobic digestion. If you have any further questions, please feel free to contact us using the details below. Thank you so much for your time and attention, and I look forward to seeing you in the next lecture of this video series. Bye.